I came in this morning to come and look at my cylinder heads, and someone was apparently here late, started the process of cutting O-rings into these heads. So you can see this one here, no O-ring, that head, no O-ring, but this one has a groove cut in it, and that groove is where essentially stainless steel wire gets installed, and it's going to create basically a high spot on the cylinder head that's going to push into the gasket, which crushes the gasket a lot in that one very small space. So it's basically going to, as you torque the head down, the pounds per square inch that is going to be exerted on the gasket right around the cylinder is tremendously higher than the rest of the area. And so you're not going to have any leakage of combustion from the combustion chamber into the coolant or oil journals. The downside to it, depending on how aggressive you go, you may end up with some leakage from coolant to oil and whatnot, because the gasket might not be able to seal quite as well on that side. So you end up maybe with a little bit more coolant blow-by. But at this power level, we're probably not going to run into that. That would be for considerably 1,000 horsepower plus type of stuff. But at 5, maybe 600, you know, not really an issue. The other kind of smaller issue is once you do this, you will not blow a head gasket under compression. That meaning that if something happens that's wrong, like a cylinder goes lean, or you run too much timing or lose timing sync or whatever, and it normally, the weakest link in this process between the cylinder and the head is the head gasket, and normally where it would have blown the head gasket out, now because that O-ring is putting all that pressure, holding that head gasket, basically keeping it from blowing, you could end up cracking a sleeve or bending a rod more likely than blowing a head gasket, which is a lot more expensive to fix. If you crack a sleeve, that's a whole new block. You bend a rod, as long as it doesn't break, you might be okay, but they tend to break. So yeah, O-rings are really cool for never having to worry about a head gasket again, but they do have a couple of small drawbacks. But yeah, this is gonna be awesome. I'm super excited. I didn't expect to see that. Have to see if we can get some video of the other ones being done. And this is a custom register plate from BHJ Incorporated, and it uses this fun cutter and this little burr on the end of it to cut that. And these are machined specifically for the Subaru. We actually have these for a couple of different cars. A lot of you know me from my days in the SRT4 circuit, and we have the O-ring cutter for the SRT4 as well, which also works on the 420A neon heads, and actually a couple other Chrysler cylinder heads share the same geometry, so we can cut O-rings in those. And you can see, because you change with this bit where the O-ring is, so all you need is the register plate that essentially bolts to the engine, or sorry, bolts to the cylinder head, and then you set the diameter and the depth. Yeah, and we can actually get these. I think we have one of these for a Suzuki as well, 4-cylinder Suzuki, like the SX4, and then they make these for the Evo, which we probably have an Evo one, I would guess, 4G63 one as well. So they're good to have if you're trying to push the envelope and you're tired of having head gasket issues. So there it is. So Andy came in today and finished the O-rings in my heads, which is awesome. Can't say thank you enough to that guy for getting this taken care of. It's not a job I was really comfortable doing by myself. I'd love to do it and learn it, but if I screwed up, I'd be out cylinder heads. So here they are, head 1, head 2. You can see there is the O-ring around each of the cylinders. Same thing over here. And he took video, fortunately, so I'm going to get that video attached to this. Learn something, guys. This is the guy that builds our
1200 horsepower Pro Drag motors. He put together the motor for the Black Widow, the world record half-mile car, and he was kind enough to take video of him putting O-rings in these heads. So enjoy.
Alright, so what we got going on here is we're going to O-ring these cylinder heads. So we have already sanded them flat on our, it's over there somewhere, granite block. Super smooth. Back over here. You can kind of see the reflection. Yeah, there we go. Reflection off of the heads. So they're down to about a 2000 grit. That ensures that they're really, really flat. And then I've gone ahead and filled these coolant jacket ports with paper towel. Make sure we don't get any shavings in there. That would not be fun. And then I've made a little mark, and you can kind of see it there. Yeah, that is just back from the edge of the combustion chamber. That will line up quite well with a mark we've made here on the head gasket just inside the fire ring. So when we cut a groove into here with this tool over there and this register plate here, which we'll see here in a bit, then we're going to drive some stainless steel wire in that groove, and it's actually going to stick out above the head surface. So when we clamp it down onto the gasket, it's going to press that wire into the head gasket and make a really, really tight seal, keep all the cylinder pressure in there, and that allows us to do some fun things. Alright, so change it here, and next step will be making some aluminum chips. So now I've got the cutter head mounted to the register plate here that is bolted to the cylinder head, and as you can see this way, there's a carbide bit in there, and try not to block all the light. Ooh, flashlight, good idea. Oh, cardboard. Party mode. Come on. Here we go. So you can see as I move this back and forth, cuts a little bit. So I'm gonna go ahead. And you just keep going around. There's an adjustment in the shaft of this that allows me to control the depth of this cut. And I'm just going to take our time here because you only get one chance. Pretty exciting, I know. Anyway. Alright, so I've gone ahead and finished the cut down to the depth that I've set here. And I will remove the cutter. Set that over here. And then now we have dial indicator. I don't know if we can see this very well. Well, little camera angle adjustment. So right now I've got it set just on the head surface, and we're right at 0. So that's, yeah, there we go. Yeah, that's pretty close. So now I'm going to go ahead and drop this down into the groove we just cut. And as you can see, we're down about 15 thousandths of an inch. So we're going to check them at all 4 corners here. Right at just below 15. Go over here. 15. We want to check at least 4 spots. Make sure that we're getting a nice even cut so we don't end up deeper or shallower on one side. And so we're a little light there. You can actually adjust it by about, a 1/4 to 1/2 thousandths depending on the pressure that you use on the cutter head. So we've determined the width of our very neatly assembled wire here. And we will cut the depth so that when we put this wire in, it sticks out certain amount that we want, which is going to depend on the type of fuel we're going to be running, the boost levels we're going to be running, the type of head gasket we're going to use, the type of deck surface that it's going to be clamped to, aluminum or steel, and there's a lot of factors that affect that. And so now we need to put the cutter head back in. Be this here guy, go careful, don't screw this up, set it in there, get these clamps back down, and tighten these down, and then we're going to do it again. Alright, so I've made our final cut, vacuumed all the chips out, or most of them, and removed the cutter head here, and as you can see we have a really nice ring cut in there, and yeah, you can kind of see, well, I can feel it but you can't, that we're gonna go ahead and cut this other side and then move on to the next step. Okay, so we got both rings cut in this head. Obviously the register plate removed, all the little paper towels pulled out of the holes. Went ahead and vacuumed out these ports, and then used a little compressed air to make sure we got all of the chips and everything out of here so it's nice and clean. We're good to go. So I've taken a piece of bundle of stainless wire. It's very nicely wound here. Take a section of it that I've cut off, and I've taken the end, see if you can, nope, not gonna do it. Anyway, I've used our piston ring filer, and I've cut it very straight and square to the direction of the wire. Make sure we get a nice clean full contact when we finish this ring in here. So it's very important where you put the ends of the rings, because you want that on the tightest clamping area on the head, which typically is where you have the most surface area and directly in line with a stud holes. We got option here, we could go over here, or any of these. I like to use these two center holes. You got the most surface area. Seems to work pretty good so far. So we're going to take this, we're going to start it, and we're going to gently push it into the groove, just barely in there enough to hold it, get it close. The wire is actually slightly wider than the groove, so when we do the final install, it'll smash down in there and stay there. So we don't want to seat it all the way yet. We just want to get close. Try to, it keeps wanting to pop out of here. Okay, that'll be close. We're going to take marker here, just mark it. This is going to be a bit long. We'll file it shorter later. No problem. Go ahead. I just use angle cutters. Go ahead and cut. There we go. Okay, I've cut, and then with the ring filer filed the end, so now both ends are nice and straight. I like to set them together to make sure that they're both cut at the same angle. Probably hard to see on camera, but yep, looking pretty good. So start back in here. See, I'm guessing this is going to be long. We'll have to trim it again. That's okay. Come on, baby. Alright. And then we're going to press wire in there. And we might actually be too short. Let's get it all the way down in there. Yep, cut it too short. Sweet. Throw it away and start over. Alright, cut a new wire. Last one was too long. So we're going to put this in. If you don't think that your stainless wire is going to go in perfect, just throw it away and start over. A lot cheaper than pulling your motor to replace your blown head gasket. And hopefully nothing else broke. So as we come around, ooh, it's looking good. So when I press this in just by hand, I can see there's just a slight gap right there, which I'm okay with, because as I tap this in and everything gets tight, that gap's going to close just slightly as the wave in here gets pressed even. So we're going to start at one end. We're going to use our super sweet handy dandy plastic screwdriver, or anything plastic will work. You don't want to hit this with something that is going to damage the head surface, because obviously once this wire is in and sticks above the head surface, you cannot resurface this. Okay, so now it's down. That's gonna be perfect. So I'm gonna go ahead and get a little more aggressive with it and drive this in, but I have found this shakes the camera to the point it'll make you throw up. So I'm gonna go ahead and stop, and we'll be back once I'm done. Alright, we're back. So I've finished using my plastic screwdriver here to tap the wire in as far as it's gonna go. Now we're gonna use pretty standard engine building tool deck height gauge here, and we're going to set it up so that we zero it out on the deck, and then come up onto the wire here. See the needle move a little bit, and alright, so what we're looking for is to make sure that the wire is even all the way around. We don't have any big wrinkles in it. And make sure that we've got it all the way down in that groove. Okay. Alright, so we're within half a thousandths around here. So typically, especially since there's just slight gap right here, once we torque this down and torque these head studs real tight, any little slight indifferences here will be smashed out, and it'll be a pretty even seal. So we'll go ahead and repeat process for this guy, and then switch to the other head, do the other two. We'll be all done, and then we'll be ready to bolt these heads on. Okay, so we finished this last one. Go ahead and take a little look. Now you can see, yeah, right here, you can just see that gap. That's about as big as a gap as I would call acceptable. If it was any bigger than that, say we need to remove it, which is a fun process. You basically take a really small drill, maybe one that's used for cleaning like a welder tip or something, and you go somewhere over here maybe, or somewhere where you got a lot of surface area between these cooling jackets, and you just drill a tiny little hole on the outside of the wire so you can get a real small pick in there and then lift the wire out, and that works pretty good, and then you can save the head. But in this case, we're just gonna run it. So I can just barely feel that with my fingernail just almost doesn't even catch on it. So there you are. That's some O-ringed heads. Here's the other guy, and you can see I've alternated the gaps. I got one going to this port, and then one over here going to that port. And next step will be getting the block ready for these babies to go bolted on there.